Hi students, in this session we will do some problems with respect to the inverse Laplace transform. That is, we will do some problems regarding inverse Laplace transform. That is, how to find out the inverse Laplace transform of a given function. So if there is a function, okay, they had given the function as x of s. See, they are given the function of x of s equal to s plus 4 by s square plus 5s plus 6. That given something like this. So we have to find out the inverse Laplace transform. That is, we have to get the original function x of t. Already they have given the Laplace transform. They have given the Laplace transform function. So for that, we have to find out the original function x of t. Okay. So here you all know the formula for inverse Laplace transform. So by using those formula also, you can find out the value of original single x of t. That is, you know the value of inverse Laplace transform x of t formula. Okay, but doing the problem with the formula is a somewhat difficult. Okay, it will take more time. For that, for inverse Laplace transform, we will go for partial fraction method. We will go for the partial fraction method because you are all familiar with the partial fractions. You already know, you studied the partial fractions. So we will find out the inverse Laplace transform of the given function with the help of partial fractions. So partial expansion method, we will go for that one. So here by using the formula it will take more time, hence I am going for the partial fraction, using the partial fraction for finding the inverse Laplace transform. Okay, here the problem is what they are given. They given the Laplace transform of x of t, that is x of s equal to s plus 4 by s square plus 5s plus 6. They are given something like this. So from this we have to find out x of t. First, I have taken x of s equal to s plus 4 by s plus 3 into s plus 3. Simple. S square plus 5s plus 6. So s square plus 5s plus 6 can be written as s plus 2 into s plus 3. S plus 2 into s plus 3. Okay. So the middle term will be addition of two terms and the last term will be the product of two terms. We all know this. So 6 can be written as 3 into 2 or 2 into 3. So 2 plus 3 will give 5. Hence I can write this s square plus 5s plus 6 as s plus 2 into s plus 3. So I rewritten this as s plus 2 into s plus 3 because we are using the partial fraction method. So this can be written as, if I write this as a by s plus 2 plus b by s plus 3. A by s plus 2 plus b by s plus 3. Okay, I have to find the values of this a and b. If I on the values of a and b, then I can easily find out the inverse Laplace transform of the given function. So first I converted this into the product of two terms with respect to s, that is s plus something into s plus something, or s minus something into s plus something, so like this. Okay, and then I written this function as a by s plus 2 plus b by s plus 3. Okay, so if you go for the LCM, a into s plus 3 plus b into s plus 2 divided by this one. So a into this one plus b into this one gives this one. So I have to equate. I have to equate. From that I have to find out the value of a. So simply I can find out the value of a by using this method. See, I can find out the value of a as a equal to, I will multiply this x of s, this function, with s plus 2 because a is upwards s plus 2. So a is with respect to s plus 2. Now I am finding the value of a. I have to multiply s plus 2 with the complete function. This is x of s. So with complete x of s. And their substitute. So here s plus 2 equal, make s plus 2 equal to 0. They say s equal to minus 2. Substitute s equal to minus 2. Simple logic. So if you want to find out the value of a, multiply with s plus 2 to the complete x of s and substitute s equal to minus 2. So if you multiply s plus 2 this equation, what happens? S plus 2 gets cancelled. And I am substituting s equal to minus 2. If these are not cancelled, s equal to minus 2, then it will become infinity. For that, first I am cancelling this one and substituting s equal to minus 2. Okay, so that's a simple logic. So s plus 2 into x of s, complete function at s equal to minus 2. So next, s plus 2 and s plus 2 gets cancelled. I have s plus 4 by s plus 3. S plus 4 by s plus 3. At s equal to minus 2. Substitute minus 2. So minus 2 plus 4 by minus 2 plus 3. That is 2 by 1, simply 2. So the A value is 2. In the same way, if you want to find out the value of B, what do you do? I have to multiply the function x of s with s plus 3, and I have to substitute s value as minus 3 because s plus 3 equals 0, so s equal to minus 3. So B equal to s plus 3 into complete function at s equal to minus 3. So if I multiply this function with s plus 3, s plus 3 gets cancelled, and I have s plus 4 by s plus 2, where s will be equal to minus 3. Substitute minus 3 plus 4 by minus 3 plus 2. So that is 1 by minus 1. This is minus 3 plus 4, 1. Minus 3 plus 2, minus 1. 1 by minus 1 will be equal to minus 1. So finally what I got? I got A equal to 2 and B equal to minus 1. Substitute this in this equation. Now our x of s will be equal to, 2 by s plus 2. 2 by s plus 2. And B value is minus 1. So minus 1 by s plus 3. As A equal to 2, I get 2 by s plus 2. And B equal to minus 1, I get minus 1 by s plus 3. So x of s I had taken as 2 by s plus 2 minus 1 by s plus 3. So if you go for the inverse Laplace transform of this on both sides, then I can easily get the function of x of t. So go for the inverse Laplace transform on both sides. Take the inverse Laplace transform on both sides. So x of s, inverse Laplace transform. We all know Laplace transform of x of t equal to x of s. So inverse Laplace transform of x of s equal to x of t. So x of t. And then I need the inverse Laplace transform of this one. Inverse Laplace transform. First, you all know, already I proved this one. That is Laplace transform of, already you know, Laplace transform of e power at into u of t will be equal to 1 by s minus a. I already proved this. Laplace transform of e power at into u of t will be equal to 1 by s minus a. In the same way, Laplace transform of e power minus at into u of t will be equal to 1 by s plus a. You know this formula, basic formula. Okay. So by using this, I can get the inverse Laplace transform of this one. So Laplace transform of this one is this. So I need in this one inverse Laplace. So bring L this side. That is inverse Laplace transform of 1 by s plus a will be equal to this one. So I know Laplace transform of e power minus at into u of t equal to 1 by s plus a. So inverse Laplace transform of 1 by s plus a equal to e power minus at into u of t. Use this formula. Use this formula here. Okay. First, 2 is constant. Bring outside. So I have written 2 as is. Next 1 by s plus 2. So here 1 by s plus a. So I have 1 by s plus 2. So in place of a, I have 2. So the formula is e power minus 2t into u of t. So here I did e power minus 2t into u of t. Just by using this formula. By using this formula. Next, in the same way, minus 1. Bring minus 1 as outside. So minus 1. 1 into anything is 1. So if you write 1, if you leave 1, there is no change. So minus c. 1 by s plus 3. So next again 1 by s plus 3. That is in place of a we have 3. So the formula is e power minus 3t into u of t. E power minus 3t into u of t. So finally the x of t will be equal to 2 into e power minus 2t into u of t minus e power minus 3t into u of t. So in this way we can easily find the inverse Laplace transform of a given function. If they are given the Laplace transform of a function, I can find out the inverse Laplace transform using this partial fraction expansion method. Simply, easily. Okay. For this reason, I am going with this method rather than using the formula, direct inverse Laplace transform formula. But here we have to know these formulas. Hence, I had gone for the basic function Laplace transforms. So all for the standard functions, I had given the Laplace transform. Those will be useful while you are going for solving the problems. So in problems, all those formulas will be useful. That's why in the previous classes, I had gone for the Laplace transform of some standard functions. From there, I used this formula in this problem. Okay, and I solved this problem very easily. Okay, this is how to solve whenever they are given a function Laplace transform. Whenever they are given a Laplace transform, for that the original function x of t, that is the how to get the inverse Laplace transform of a given function. This is the procedure. I hope you are all clear, and I hope you will do the problems based on this inverse Laplace transform. Now we will see another problem with respect to inverse Laplace transform. Here the function is x of s equal to s cube plus 1 by s into s plus 1 into s plus 2. For this, we have to find out the inverse Laplace transform. Here also we will use the partial fraction method. Okay, so we will see how to solve this one. So first, this is a given problem. See here, the order of the numerator is 3 and the denominator s into s plus 1 into s plus 2. So in the first problem I had given it a complete equation. Here they already gone with respect to the multiplication, that is s into s plus 1 into s plus 2. They already given that one. Now if I want to get the complete equation of this one, how can I get? If I multiply these two, s plus 1 into s plus 2 is s square plus 2s plus s plus 2, that is s square plus 3s plus 2. And if I multiply this with s, I will get s cube plus 3s square plus 2s. Simple. That is, this one is equal to s cube plus 3s square plus 2s. So the given problem x of s will be equal to s cube plus 1 by s cube plus 3s square plus 2s. Okay. Now you can easily identify that the order of numerator and order of denominator is same. Here the order of numerator and order of denominator is same, but in the previous problem the order of numerator and order of denominator is not same. So I gone for the partial fractions directly. But here the order of numerator and the order of denominator is same, so we cannot go for the partial fractions directly. That is, partial fractions directly cannot be obtained if the order of numerator and denominator are same. The partial fractions are not obtained directly. So what you have to do? So for that I have to go for the division of this one. Okay. So x cube plus 1 is dividing with this one. Is dividing with this. Simple. If I want to divide 21 by 5. If I want to divide 21 by 5. What I will do? 5, 21. So 5 fours 20. So the remainder is 1. In the same way, here also I am going to divide this s cube plus 1 by s cube plus 3s square plus 2s. So I am writing the denominator s cube like 5, s cube plus 3s square plus 2s. This is the numerator s cube plus 1. So this is multiplied with 1 time. So this is multiplied with 1 time. So what happens? S cube plus 3s square plus 2s. If you multiply this for 1 time, I will get this one. Okay. Now see, subtract this one. Subtract minus, subtract. S cube cancel. So in this there is no s square term, but here we have s square term. So minus 3s square. There is s term. There is no s term. So minus 2s, and there is no constant. Here is a constant. So plus 1. So I am subtracting this from this one. So I got minus 3s square minus 2s plus 1. So this one. I got this one. Okay. Now, so see, we equate this to this one. So 5 of 21 will give 5 4 21. In the same way, s cube plus 3s square plus 2s of s cube plus 1 will give 1, and the remainder is this one. So if you want to get the 21 plus 5, how can I write? So here 4 plus 1 by 5, 4, okay, plus quotient plus remainder, okay, 4 plus 1 by 5, okay, that is 5 fours 20 plus 1 by 5, that will be equal to 21 by 5. In the same way, here also I have to consider 1 plus this one, 1 plus this one. So in this I had taken minus as common. So it becomes 3s square plus 2s minus 1. So here I written 3s square plus 2s minus 1. So there minus common. So actually here we have to write plus into minus. As I had taken minus common from this one, so I had written minus this one, minus here. Otherwise, if I write as it is here, I have to go for plus here. Okay, for your easy understanding, I had taken the minus outside. Okay, and plus into minus. So it is easy to understand. So 1 minus 3s square plus 2s minus 1 divided by this one. Simple. 4 plus 1 by 5. In the same way, 1 plus this one by this one. So 1, actually I have to write plus, but taken minus common. 1 minus 3s square plus 2s minus 1 divided by s cube plus 3s square plus 2s. Okay. Now finding the partial fraction using the partial fraction method is easy for this one. So you can go for the partial fraction for this one. Now I'm considering this one only. 3s square plus 2s minus 1 by, already I know this one. Actually this is s cube, not square. Okay. So same s cube. So for this one, that is s into s plus 1 into s plus 2, the given one. Okay, that will be written as a by s plus b by s plus 1 plus c by s plus 2. So if you want to find the s, what I have to do? I have to multiply this term. I have to multiply this term with s and keep s equal to 0. As I multiply s, this s will get cancelled and substitute s equal to 0 in this case, first term. If you want to find out the value of b, what do you do? I have to multiply this whole term with s plus 1, then s plus 1, s plus 1 and substitute s equal to minus 1. If I want to get the c, I have to multiply whole this term with s plus 2 and I have to substitute s equal to minus 2. So that's what I did there. So a equal to, a allows, how can I get the a equal to 3s square plus 2s minus 1. That means I have to multiply this whole thing with s. S gets cancelled. Remaining one is this one. So 3s square plus 2s minus 1 by s plus 1 into s plus 2 at s equal to 0. Substitute 0, 0. So 0, 0. Everything. What happens? What is the value of this one? That is nothing but 1 by 2. Okay. So substitute 0. This one. Substitute 0. 0. Okay. So answer is 1 by 2. For B, multiply this with s plus 1. So s plus 1 gets cancelled and we have 3s square plus 2s minus 1 by s into s plus 2. 3s square plus 2s minus 1 by s into s plus 2. At s equal to minus 1, substitute minus 1 here. Minus 1 here. 3 minus 2 minus 1 by minus 1 of minus 1 plus 2. So this is 3 minus 0. 0 by anything is 0. Answer is 0. So b equal to 0. How can I get the c? Simply c will be getting by multiplying s plus 2 to this equation. So s plus 2 gets cancelled and we have this one in there. I have substituted s equal to minus 2. So 3s square plus 2s minus 1 by s into s plus 1 where s equal to minus 2. Put this one 12 minus 4 minus 1 divided by 2. Okay. So this is minus 2. Put here as minus 2. Minus 2 plus 1. Minus 2 plus 1 is minus 1. So minus 1 into minus 3 is 2. So answer is 7 by 2. 12 minus 4 minus 1. 12 minus 5 by 2, that's 7 by 2. Okay, I got the values of A, B, C. 3 values. So substitute those 3 values in this equation. A is minus 1 by 2, B is 0 and C is 7 by 2. So what is the value of x of s? Now x of s equal to 1 minus. So this can be written as this one. So 1 minus 1 by 2 s by s plus 0 by s plus 1 plus 7 by 2 by s plus 2. I substitute the values of a, b and c. Okay. So x of s that is nothing but Laplace transform. X of s. So x of s equal to 1 minus of minus plus 1 by 2 into 1 by s. 0 by anything is 0. Okay, no need to write this one. Next 7 by 2 into 1 by s plus 2. 7 by 2 into 1 by s plus 2. Simply. So this is minus into minus plus, minus into plus, minus. Expanded. Now taking inverse Laplace transform on both sides. Taking inverse Laplace transform on both sides. So x of s will become as x of t and inverse Laplace transform 1. Nothing but we all know. What do we know? We know Laplace transform of impulse function will be equal to 1. So inverse Laplace transform of 1 equal to impulse function del of t. So del of t. In the same way, we all know Laplace transform of u of t equal to 1 by s. So inverse Laplace transform of 1 by s equal to u of t. So here for 1 by s, the inverse Laplace transform is u of t. So constant 1 by 2 into u of t. And so this is for inverse Laplace transform of 1 by s plus 2. That is nothing but e power minus 2t into u of t. So you already know. So Laplace transform of e power minus at into u of t will be equal to 1 by s plus a. So here in place of a I have 2, 1 by s plus 2. So the inverse Laplace transform of 1 by s plus a equal to e power minus at into u of t. So in place of a I have 2, hence we are writing e power minus 2t into u of t. So this is how to get the inverse Laplace transform when the order of numerator and denominator are same. So if the order of numerator and denominator are same, we have to follow this procedure, and then I have to go for the partial fractions, and then I will easily get the inverse Laplace transform. That is, at the end I have to go for inverse Laplace transform on both sides. Here also I used the Laplace transform of some basic functions. Hence, while explaining the Laplace transform, I gone for the problems with respect to the finding the Laplace transform of some basic functions. So those basic functions Laplace transform is useful while performing the problems, while solving the problems. Okay, so these are some of the problems. Okay, how to get the inverse Laplace transform. Okay, I hope you are all clear with this concept, inverse Laplace transform. Now you can do the problems based on this inverse Laplace transform. Okay, practice more number of problems. If you have any doubts, you can ask me at any time. So this is today's class. So we are finishing today's class. Thank you one and all.